Hello everyone, in this video we are going to cover how to use the MUX board with a multiplexer to interface with analog devices, in this case potentiometers. Okay, the multiplexer board can be connected directly to this row of headers. Just certify that we need just to certify that there is these negative and positive pins, and they will connect to the negative and positive pins on the headers of the modules. Okay, it's just a matter to certify that they are all connected. And now this works for the Teensy, the T32 model with the Teensy 3.2, but it is the same for the Arduino. Okay, if you are an Arduino user, just bear in mind that this is just the same IDE, the same programming that can be used for the Teensy and for the Arduino. The multiplexer board have negative pin, positive pin, and then there is the signal, this S0, S1, S2 and S3 to interface with the multiplexer, and then we have the enable pin and the signal pin. Okay, let's start with powering the module. Black goes to the negative, the white goes to the positive, and here, because the Teensy works at 3.3 volts, we connect the power on this bus, the 3.3 and ground bus. Then these data pins, S0 to S3, goes to the Teensy, and I'm going to connect them here, pin 9, 10, 11 and 12, and the enable and signal. The enable is the yellow, the signal is the orange. Because we are using analog devices, let's connect them to the analog pins on the Teensy. In this case, the signal is the orange, is connected to the A1, which is the 15 on the Teensy, and the enable goes to the pin 14. The enable can be a digital pin, doesn't need to be an analog pin. Okay, let's connect the Teensy. Okay, on the Arduino IDE, let's open the multiplexer library example for read analog signals. And here we are including the library. If you want to know more about this library, there is a link here that will be on the description of this video. And here we need to change these pins according to the pins we have just connected. This is the enable pin, and it's the, let's just certify, the enable is the yellow, and the yellow here is connected to the 14. And then this is the data pins. They are on the S0 is the gray one, the S0 is the gray, and the gray here is pin 9, pin 10, 11 and 12. And the analog pin is on pin 15, which is the A1. Okay. In this loop, we have a for loop that will go to each one of the multiplexer addresses, and we are printing this data that will handle the read from the address of the multiplexer, and we will print all the 16 addresses in one row, and then we will change the line. Okay, here let's add a delay, and let's see what happens. Let's make a shorter delay. Okay, as we can see, we have our potentiometers data being printed. Here, as you can see, it's very easy to work with. Now, we have 16 potentiometers here. Let's add another multiplexer. Okay, just certify that they are connected correctly, and there is not any pin left unconnected. Now, the data pins can be daisy chained, they are shared, they are all the same, doesn't matter if we use one or more multiplexer, and we can daisy chain these pins going from one multiplexer to the other, like this. Verify that the S0 goes to the S0 on the other multiplexer. Power the board. White is the positive. Okay. And now the other enable and signal. Let's connect them to the Teensy right here, and this enable is the brown cable. It's on the pin 17, and on the program we need to instantiate another multiplexer. Okay, let's call this MUX 1. We need to change it here, and let's add another MUX. Let's call it MUX 2. The data pins are the same, we just need to change the enable pin. It's the brown, it's 17. And on our loop, we will do another cycle. And this time is the MUX 2. Here I'm just adding a separator to visually be more easy to understand what is going on, and connect the multiplexer. Oh, and we need also to instantiate the MUX 2 on our setup. Okay, and it's the red is on the 16 pin. Okay, A0, A1, A2. Upload. Let's see what we got. Okay, okay, as you can see, we have our analog devices, and you see how easy it is to connect 32 potentiometers Let's put them at 0, all of them. Like this. As you can see, it's fairly easy to interface with multiplexers.